Hi everyone, I'm Mikhail. Welcome to the Dark Wire Labs YouTube channel, where we break down network technologies and implement them with real code. In today's video, we will develop our own tiny VPN protocol and build a working client and server as a practical example. Before we start, a few words about myself. I've worked in networking and network security since 2008. While I enjoy learning new technologies, what I enjoy most is building my own solutions and understanding how things work under the hood. After years of working with VPN technologies and protocols, I decided to build my own VPN from scratch. Today, we'll review VPN fundamentals, including packet encapsulation and the minimum requirements for building a VPN. Then, using AI, we'll implement a working solution and test it across multiple environments, from Docker-based lab setups to a cloud server. And finally, a home router running OpenWRT. So let's get started. Before we start coding, let's quickly recall what a VPN actually is. A VPN, or Virtual Private Network, is a technology that allows traffic to be securely transported between two or more endpoints over an untrusted network, as if they were directly connected to the same private network. In practice, this means traffic is encapsulated, often encrypted and authenticated, and transported through another network, usually the internet. There are many different types of VPNs. Site-to-site VPN solutions, Layer 2 or Layer 3, remote access, SSL VPNs, etc. One of the industry standards is IPsec, but there are many other protocols commonly used like L2TP, PPTP, OpenVPN, WireGuard, SSTP, and other SSL or TLS-based protocols. In today's video, we'll focus on a very simple VPN protocol whose only job is to encapsulate IP packets inside a transport layer protocol and carry them between two VPN endpoints. For simplicity, I'll skip encryption and authentication. I'll focus only on packet encapsulation. This should be similar to IP/IP or GRE tunneling, but I want this protocol to operate on a transport layer to support network address translation. Now we are ready to build our first prototype. I'm going to use ChatGPT to write code for me. In this slide you can see the requirements that I listed. So I put these requirements in the ChatGPT and asked to generate program for me. I also specified that I'd like to run it in a Docker container, so I'm expecting ChatGPT to provide a Docker file for me as well, and some instructions how to run it. So just to summarize the requirements. So that's going to be a single application. We are not implementing client-server architecture yet. So the target operating system is Linux. And for future, our target is OpenWRT. So in Linux, we are going to use the tunnel interface, and whatever packets come to the tunnel interface should be encapsulated in a UDP datagram and then sent to destination. And of course, this UDP datagram will also be encapsulated in an IP packet before it can be sent by the operating system. And the same applies to incoming traffic from the VPN peer. So it will be decapsulated and sent out from the operating system kernel. So in this example, both source and destination ports will be the same. I decided to use port 5555. The transport protocol is UDP. And let me show what ChatGPT generated for me. So after I provided all the requirements ChatGPT agreed the architecture with me and the scheme of the protocol. So we agreed to use just simple encapsulation of IP packets into UDP datagrams. That's it. And yeah, ChatGPT provided code using C language. Honestly speaking, I don't know this language, so here I fully rely on ChatGPT. And yeah, it also provided some instructions how to compile it, how to create tunnel interface, and so on and so forth. So as a result, I received a Docker file, a shell script to create tunnel interface and run the program, and the C program itself. What I need to do, I just put it in my folder here, and next I'm going to create to build a Docker container and then to run 2 instances of the container to test it. So for Docker containers, you need Docker desktop, and to build the container, you need to write command docker build. So it's downloading the Docker container image, running the scripts, and so on. Honestly speaking, I had to do multiple interactions while speaking to ChatGPT in order to get the working example. But now you see it was built successfully. The program was compiled because otherwise we would get some errors. Now it's time to run instance of this container. So I'm going to run it where the tunnel IP address is this one. The peer IP address is this one. Actually, this is default Docker network. And by the way, I also had to create a Docker network. But yeah, you simply need to follow steps from ChatGPT after you install the Docker desktop. So let's run it. I think it's running successfully. Now let's run one more instance that will represent second peer, and respectively IP addresses needs to be updated. So now I go to Docker desktop. I see 2 containers are running. I'm going to open another terminal. Checking interfaces here. Yeah, the tunnel interface was created. And by the way, let's also check. So you see that's the C program was successfully compiled. What I'm going to do, I'm going to ping the opposite side of the tunnel. I'm going to ping the tunnel IP address of the peer. You see it's responding. So it looks good, but we need to confirm that traffic is actually being encapsulated. So what I'm going to do, I'm going to open another terminal session to the second instance of container. Yeah, so that's the other peer. And I'm going to run TCP dump to capture traffic and to see what's going on. So first of all, I'm going to capture traffic from the tunnel interface, because here I should only see ICMP traffic and nothing else. So I use TCP dump for tunnel 0 interface. Let's see, yeah, I see ICMP echo. It's good. Now I'm going to run packet capture for the actual network interface connected to Docker network. So I'm going to do TCP dump -I Ethernet 0. And here, this interface, it represents the underlay, while the tunnel interface represents the overlay. So in the underlay, we see UDP datagrams on source and destination port 5555, where the IP packets are encapsulated. And in the overlay, we only see ICMP packets. So here, ICMP is encapsulated in IP, IP is encapsulated in UDP, UDP is encapsulated in another IP, and this packet is sent to the destination. Looks good. So this chapter is completed. Let's move on to the next chapter. Now it's time to update our program to move to the client-server architecture. So the idea is that the server should be listening to incoming connections on UDP port 5555, while client should use random source port, but use port 5555 as the destination. And of course, the server should reply back to the client using the source port that was chosen by the client, the same random port. So this solution should be compatible with NAT. If a client is behind the NAT, well, the NAT should not break this VPN tunnel because although the source address is changed, but still the protocol should operate normally. So I have asked ChatGPT to modify the initial prototype program and to split it into client and server programs. So let me show what I've got. So I've got these two C files, one representing server and one representing client. I've also got run script, it's shell script. I asked ChatGPT to use the same shell script for both client and server, but only to specify in the argument what role should this host run, and updated Docker file. So as you can see here, we are compiling two programs for the same image, for the same container, I mean. Yeah, and then run the script. So based on the argument, it will either run client or the server. So let's try it out. So first of all, I need, once the files are available in the folder, we need to build the container. And I just recall that before that, when you initially set up your Docker, you need to create a Docker network for your containers. Okay, so the container has been built successfully. Now I can start server first. So here, as you can see in the arguments, I need to specify the tunnel IP address of the server and the UDP port number to listen to. Right. Now let's start the client. So for the client, I also specify as argument tunnel IP address. This one is the server IP address, real IP address, underlay IP address, server port, and the client port, the source port. We can put anything we like here. Okay, so I'm going to the Docker desktop. I see two instances are running. I'm going to connect to one instance. This is the server from the IP. And I'm going to connect to the client. Yeah, this is the client. I'm initiating ping to the server. The server is responding. This is a good sign. Then on the server, I'm going to run TCP dump. So as you can see, the server is getting incoming packets from the client. The source port is 40,000, like we specified. The destination port is 5555. So this is UDP. That's encapsulated payload. And then the server responds to the client using the client port 40,000. So it's all good. Next step would be to run this VPN server on a VM in the cloud. In the next chapter, we'll deploy our VPN server in the cloud. I created a virtual machine in AWS, and I'm going to run VPN server on that machine. I've already copied the program itself and the shell script to that virtual machine. So let's just summarize the plan. So first we need to run the server in AWS, then we need to run client again in the same container on my home computer. And as my home computer is sitting behind home router with net, when packets from the Docker container go to the cloud, the source IP address will be modified. So I'd like to test and make sure my VPN tunnel is still operational, even if the client is behind the net. So let's go ahead. So I've already created virtual machine in AWS on the free plan. We just need to keep in mind that we need to allow inbound UDP connections on port 5555. And basically, that's it. The VM is running Ubuntu Linux, so the program which we previously compiled should be compatible with its CPU architecture. So that's my virtual machine. As you can see, I have copied the program and the script. We need to make these files executable. Okay, that's good. Now we need to run the server. When running the server, so we'll run it from the script, we need to supply right arguments. So we'll tell the script to run the server application to use 10.0.0.1 as the tunnel IP address and to listen on port 5555. Okay, you can see this error that address already assigned. I think that's because I ran this script before, so tunnel interface already exists, but that's okay. Okay, next we need to run the VPN client in the container. So as we previously built the container, I don't need to rebuild it. I just need to slightly modify the attributes. So let me clarify what the difference is. Actually, the only difference here is the server IP address. So that's the public IP address of my virtual machine in AWS. The rest is the same, right? Container is running. So this is my second SSH session to the server. What I'm going to do, I'm going to ping tunnel interface of the client. You see it's responding. Also, you see that now the round trip time is much higher, what proves that this is a real example. Okay, let me run TCP dump in the Docker container. So you see packets are going to the public IP address. Actually, this one is the host name of this container. And actually what I can do, I can run Wireshark on my local machine, and I should be able to see this traffic as well. So that's my network interface. I'm going to filter it because I only want to see this port 5555. So you see that's all encapsulated packets in UDP datagrams. Let's take a look. So this is the outer IP header. The source here is the public IP address of the server. Because this packet came from the server, the destination is IP address of my computer. And we see that there is UDP datagram encapsulated. One interesting thing is that here the port is not 400, it's not 40,000, but it's different. This is actually because of NAT. And in this connection, there are actually 3 points where network address translation takes place. So the first point, let's look at the outbound packets from the container. So the first address translation will be done by the Docker. When this packet leaves the Docker network, this IP address will be changed to IP address of my laptop. Just to show you, so this is my IP address. So that's one address translation. Second, yeah, and this is where actually this source port 40,000 is changed to this random port 56123. Then, when this packet leaves my home network, my home router again translates the source IP address to a public IP address provided by my home ISP. And then when it comes to AWS, the AWS itself translates IP address, but in this case, the destination IP address, because this IP address, this public IP address, it's not assigned on the virtual machine directly. The virtual machine, it has private IP address. Yeah, as you can see, the virtual machine has this IP. I'll just run like a capture to show you. For some reason I don't see this traffic. Not sure why. Yeah, for some reason it's not capturing here. I don't know, maybe some limitation, because obviously my default route is pointing there, but yeah, still, as I can capture it in other network points and then show it, so I think that's sufficient. All right, so that's it for this chapter. Next, we are going to deploy our VPN server on a router with OpenWRT operating system. There are two options how we can compile it for OpenWRT. One option is to copy the C compiler directly on a router, but this option requires pretty much memory. For example, my router, it doesn't have enough memory, so I have to follow the other option and cross-compile this from my computer and then copy to the router. So before doing that, I asked ChatGPT to review the code of the server and to adjust it for OpenWRT operating system and router architecture. So that's the new code. It was slightly updated. I'm going to use existing container to actually cross-compile. I need OpenWRT SDK for that. And before that, I need to check what OpenWRT version my router is running and what's the CPU architecture of the router. So this is my router, my home router. The SSH access is mandatory. So as we see, it has ARM CPU architecture. And the build target should be this one. And the version is 23.05.5. So next, I need to go to OpenWRT website and look for SDK for this version. So this is the target, right? What we saw on my router. I scroll it down to supplementary files. Here, I choose this file. This is archive. So I need to download it and copy it to my container. Once copied, I'm going to extract it. So the most important folder is staging dir. Now we need to set up environment. With help from ChatGPT, I'm setting the environment. So I need to do it for toolchain and the final path for the compiler. Yeah, here it is. Now I can use the compiler to compile the file. This is my file. So I use this compiler, so the output will be executable file for this specific CPU architecture. After successful compilation, I've got the executable file. Let's verify it. Oops. Since I'm running it in a container, some tools are missing and need to be installed. All right. Here it is. So we see it's compiled for ARM CPU. It's all correct. Now we need to take this executable file and copy it to the target router. I'll skip this step because it's pretty straightforward. I used SCP to copy the file. In this case, we don't use the script. We just copy the bin file. So the arguments here for the file, for the server, are the name of the tunnel interface and the port. So I have second session to the same router. You see before I ran ifconfig to see interface list. Now I'll run it again. Okay. Tunnel interface is not showing here. We need to configure it manually. This. And we need to configure IP address. Of course, we could do all this through shell script, but I didn't test it. Okay. Now let's run client. Previously I tested it already, so for the client we need to keep in mind to put the physical IP address of the router to connect to. Okay. Let me ping from the router our client. It's pinging successfully, and I should be able to capture traffic. I can do it either from the Docker container or from my workstation. Let me try both. All right. This is the client. We are getting a CMP. Now let's check the underlay. So we are getting UDP. Right. Interestingly, okay. No, just hold on a moment. Now I'm running packet capture from my workstation where Docker is running. As you could notice, the port was changed from 40,000 to 58,316. That's because of address translation in the Docker network when packets leave Docker network. All right. So we have successfully deployed VPN server in OpenWRT router and connected client to it. Just to recap what we did today. So we discussed VPN technologies, we deployed our own VPN protocol, we built prototype, which turned into the client and server VPN software, and we tested it in a Docker containers, public cloud, and OpenWRT home router. If you enjoyed this video, I can take this project further by adding encryption, authentication, and multi-client support. Let me know in the comments what you'd like to see next. See you.